Hello everyone, welcome to the session. Today I'd like to touch on zombie resources in the cloud. Um, just after doing some reading, I realized about 30% of global cloud costs actually goes to zombie resources. And what are these resources? These are basically um, the like ghosts of like deleted infrastructure, right? So basically, if you spun up an instance to do some testing, and you have like elastic IPs attached to it, EBS volumes and things of that nature, and you just delete the instance, some of those resources are left behind, and you're gonna pay for them, right? Knowingly or unknowingly, you pay for them. Sometimes it's due to lack of knowledge, and other times it's just human error, like you just forget. So what can you do to mitigate this situation is what we're gonna cover in this video. So first, I'm going to show you, do like a visual illustration just so you can see how this happens. I spun up an EC2 instance, so I'm going to just go ahead to the page. See the instance starts on the illustration. So I'm going to go ahead and terminate the instance. Okay, first I want to show you, before we do that, I'm just going to go ahead and show you the volumes attached to the instance right now. So this instance has 3 volumes. Okay, so I'm gonna go to the instance and I would terminate instance. Okay, so you see some of the volumes highlighted here, so I'm gonna go ahead and click terminate. Now, deleting this instance, if you're not aware about the perpetuity of the volumes and any other resources that could have been attached to it, security groups, IP addresses and things like that, then you would be leaving a lot of things behind which you will be paying for without knowing, right? So that's exactly what I'm trying to show. I'm going to wait for the instance to shut down, and then as well as terminate, and then we can look at the volumes. Okay. As you can see, some volumes are left behind, and if you don't delete this, you're going to be paying for this without even knowing. So I'm going to go ahead and delete the volumes. Okay, so we don't have anything left behind. Delete volume, delete, and we've got one more volume. Okay, so by doing this, I don't have to worry about paying extra later. Now that we have a great understanding of what zombie resources are and how they are created, I would like us to focus now on how to prevent them, and if they already exist, eliminate them. So basically proactive and reactive approaches. Okay, so we're going to start off with the proactive approach, okay, which would basically be to have governance by design. Okay, and by governance by design, I'm talking about infrastructure as code, right? So basically, you're going to build everything maybe through Terraform or Cloud Formation, depending on which cloud platform you have. And if it's not built by code, then it shouldn't exist. Okay. So basically, it's a tag or deny policy. You should have, it's either you have appropriate tags or the resources don't exist either, because with tags are going to help you to be able to manage your resources and get rid of whatever it is that you need to get rid of in a timely fashion, or at the time which you need to, at the time when you need to get rid of it. So tags are really, really important. And then also you have to put in place service control policies that restrict certain expensive resources from being built anyway. You have some developer just I don't know, stand up like an impossible size of an instance, maybe $1,000 per hour kind of instance, without knowing. So you just restrict such resources from being built regardless. And then also, if you were like to consult with us, we could build you some type of guardrail system so your engineers can move fast without accidentally leaving behind, resources of that nature. And then if, if you were to bring us in, we'll also, so the proactive approach only works after the fact. Anything that was built before, we still need to get taken care of, or anything that slips through the cracks, right? So that's how the reactive approach comes into play. Now, in this strategy, you would probably need to like break it up into different layers, like the networking layer, the network, compute, storage, and safety. Okay. So in the network area, what we'll be looking for here is like maybe idle load balancers, elastic IPs, entry endpoints, basically anything that is like a security hole, right? At the compute layer, we'll be looking at right sizing for resources, because it's not just about zombie resources. You don't want to over allocate resources as well. So we make sure that everything is appropriately sized, and you're using a fair amount of CPU utilization. You don't want to spin up an instance and you're only using 1% of CPU, and you're paying for that monthly, right? So it's basically an investigation to make sure that everything is appropriately sized and tagged, and it's also just putting all the measures in place. At the storage layer, we're looking for like things like orphaned snapshots, old log groups for CloudWatch. Companies often pay thousands of dollars just for that, things that are not being used at all. So those will be looked at definitely. And then for the safety first, you got to understand, like, you just don't want to get rid of stuff, because you could get rid, in the process of trying to be cost effective, you don't want to go ahead and delete data that's going to cause you more problems. So it's basically just putting the right methodology in place. You notify, you tag, snapshot, and then you can delete the workflow. It's not just about deleting stuff, right? So just make sure that we understand it. Now, I have for number 5, which is a visual illustration, I wrote like a little lambda function where I'm going to show you, how you could basically safeguard an environment in this way. Okay. So for this one, you see I declare what the mandatory tags are, which is just project and owner. The grace period, which is basically identified like a window. Okay, the grace period should be 7 days and things like that. Depending on your environment, you can have that set how you prefer. Depending on how critical data is. If you're just working with test workloads versus important production data, things like that. So depending on the environment and what you're doing, you can customize how you use that. So if you look at stage 1, it's like based on the criteria of like tags and the owner and things of that nature, you identify what the zombie resources are. Okay. Once you identify them, you delete them. But before deleting, you have to like do some kind of SNS to like notify the people that, okay, this is what was identified, okay, and in 7 days they're gonna get deleted. And you get the warning message for what is going to be deleted in 7 days, and you also get a message when it has been successfully deleted after 7 days. Now, this SNS message that you get for that 7-day period gives you the grace to be able to figure out, okay, do I need this or do I not need this? And if you do need it, then you can go ahead and tag it. You can do whatever it is that you need to do before it actually gets deleted. Now, this is a very proactive measure. This is reactive. If you had a proactive measure, you won't be able to build these resources in the first place without the right tags. So that's something to think about. So I just felt like I should show like an illustration of what the lambda function would look like that you use to take care of these type of problems in the work environment. Now, as far as the benefits, there are so many benefits: the financial benefit, the security benefit, agility benefit, and also like basically what I call CTA, which is if your bill is growing faster than your business, then you have a zombie problem, right? So you want to be able to save money, keep your environment secure, and also, you know, expand your infrastructure as your business expands. You don't want to create holes and unnecessary bills and things of that nature. So that's pretty much it. Hope you learned something today, and I'll see you next time.